I've been sitting on this investigation for over a year now, and today is the day that we'll finally be deep diving into the seed oil controversy. And here's the catch. Even if you're familiar with the anti-seed oil argument, I'll bet you've never heard some of the arguments that I'll be presenting against seed oils right here, right now. You see, while health influencers lob claim after claim without any scientific backing, there is an actual group of researchers that also believe seed oils, omega-6s, may be harmful. And yet, I've never heard anyone dive into their findings. So let's get into it. This is going to be detailed. It's going to be long. So buckle in. If you aren't familiar with what seed oils are, they're omega-6 polyunsaturated fats. And if you're unfamiliar with what that is, they're a particular type of fat, like the ones that you eat, that have a molecular structure that creates a kink, actually multiple kinks, in that structure. Now, because of their structure, they are more susceptible to damage from damaging molecules like reactive oxygen species and other free radicals that are formed by your cells under circumstances like when you smoke, when you're over fat, come in contact with air pollutants, and any number of other exposures. The point being, these fats, these seed oils, are more likely to be damaged, contributing to hypothetically worse health. I'm sure there are other arguments for their negative health consequences, but we're here to discuss the clinical data in humans. If people consume more seed oils, do they experience more health issues? That's the big question, regardless of the mechanism. Like I promised, there are researchers that argue that seed oils, these omega-6 fats, are detrimental, and there's this back and forth debate between this group and another group that disagree. These researchers put together multiple randomized controlled trials up to the point of that analysis's release, looking at seed oil or omega-6 fat consuming groups compared against non-seed oil consuming groups. So this analysis included 7 studies, and we can see them here. We have the studies on the left side. The MCS study there is broken up into 2 groups, split by sex, and we have the results on the right. Okay. If you've never seen this before, there's a 1 line in the middle, which indicates no increased or reduced risk from consuming omega-6s. If the squares and the lines move to the right, that indicates increased risk, and the opposite if it moves to the left. The overall effect, all the studies included, is the diamond. Oddly, there's 3 diamonds, and that's because the researchers have an overall diamond, including all the studies on the very bottom. And then they have split the studies if the study included omega-6s only, or if they're given omega-6s plus omega-3s, each getting their own diamond and telling a different story. This is where the first mystery begins. If we focus on the overall effects diamond, it's squarely in the middle, indicating no increased mortality risk. But if we look at the top grouping, the studies including omega-3s, the diamond leans to the left, indicating potentially reduced harm. On the other hand, the bottom grouping leans to the right, indicating potential increased harm. The combined effects leads to this neutral effect. Yet both subgroups, with or without omega-3s, are not statistically significant. So why do these researchers think that omega-6s are harmful then? Well, it comes down to the split between omega-3 inclusion. They mentioned that other studies have been confounded, muddied, by the fact that participants not only consumed more omega-6s, but also consumed omega-3s. Omega-3s are also polyunsaturated fats, but their chemical structure is slightly different and have been linked to positive health outcomes. Think like algae oil, fish oil, krill oil, salmon, and so on. Yet according to them, if you only focus on the studies using omega-6 alone, we can start to see this divergent effect. No longer is the data trending toward benefit. In fact, if we look at some of their other data, that trend becomes more clear. In these data, it's the same idea, but instead of all-cause mortality, we're looking at coronary heart disease. Here, we clearly see that the addition of omega-3s improves coronary heart disease, as it clearly shifts to the left of the 1 line. But again, we don't see that when just looking at omega-6s, the seed oils. Unfortunately, the researchers only had 3 groups of people instead of 4, like in the all-cause mortality data, because the Sydney trial only looked at all-cause mortality. They argue that if they'd had the data from the Sydney trial, they'd detect an increase in coronary heart disease. But wishes and hopes aren't going to convince us science-minded individuals, right? Fortunately, these researchers didn't stop there, and they actually got their hands on the data. But before we get to their updated analysis, which is quite revealing, let me introduce you to the disagreeing party, the pro-seed oil research group. This group wrote a response to this analysis that we just went over. Therein, they seem to almost gaslight the first group that we just went over. I can't believe I used the word gaslight, but here we are. They literally write, Ramsden et al. Have recently confirmed that many other studies have shown the consumption of vegetable oils rich in omega-6 polyunsaturated fats lowers risk of coronary heart disease. Excuse me? Did they read the same analysis that we just did? They also push back on the omega-6s alone potentially increasing coronary heart disease because there's limited studies and the results were not statistically significant. I think that's a fair point because it's technically true. Still, the lack of an effect when an analysis doesn't have enough data doesn't mean that there isn't an effect there to be detected. They also point out that other studies, especially highly controlled metabolic ward studies, where everything is given and controlled by the researchers, indicate improved blood markers from consuming omega-6s. This is also shown in epidemiological studies. We'll come back to that point in a little bit. So, Ramsden, the first research group, collapsed back in their own letter by saying Harris et al. Apparently overlooked the central finding of our analysis that omega-6 and omega-3 plus omega-6 interventions have significantly different effects on risk. Okay, Ramsden et al., I see you. They also continue to point out that the argument by Harris et al. Is inaccurately portrayed as they fail to mention the Sydney heart trial in the all-cause mortality data and the fact that most of the participants in that trial died from coronary heart disease. Admittedly, I found this rebuttal far better because it's true that the main point of the Ramsden analysis was that seed oils alone create different effects than seed oils plus omega-3s. But there's this lingering problem that we're speculating on the Sydney heart trial since we don't have that data. Or at least we didn't then. Fast forward a few years and guess what happens? The Ramsden group analyzes the Sydney heart trial data for coronary heart disease and cardiovascular death here. Now, if we look at the results of their analysis, we can see the Sydney heart trial or the Sydney diet heart study has now been added. And lo and behold, the diamond squarely shifts strongly to the right, indicating a greater coronary heart disease deaths from only consuming more omega-6 fats. Now, to be transparent, the p-value was 0.06, so technically not statistically significant, although extremely close. So now we have even more evidence that seed oils cause death. The same was true for cardiovascular death as a whole, assuming that we accept this 0.06 p-value. Wow. Okay, so I love the nuance of splitting omega-6s from omega-3s because it's true that could be a major factor in how we interpret these data. I also love that they're using randomized controlled trials, which are powerful tools of evidence. But, yes, the ass that turneth tails. But there's so much more to this story. Do we need an intermission? Maybe, I don't know, grab some snacks. The tricky thing is, should they be seed oil based or not? So far, no. But is this story about to take a turn? Well, we've discussed one perspective, and it's clearly full of potent material. But there's another perspective to be had here, so let's have at it. More recent meta-analyses have also pulled together randomized controlled trials, including more recent ones. For example, in this analysis, the researcher actually only included the same older studies from the 60s up to the 80s from our initial analysis. We can see that from the data here that we're looking at the same coronary heart disease deaths. You can see that the researcher has split studies by if they're adequately controlled or not, meaning if the studies had higher risk of major confounding, like I don't know, employing multiple changes other than just increasing omega-6s, or the studies weren't randomized, and any number of other potential biasing factors. As we can see in the studies that fit as higher risk of bias, omega-6s reduce risk of coronary heart disease death. But when we focus on the better controlled studies, that benefit is lost. Obviously, it seems nonsensical to go by the poorly controlled studies, but even the better studies indicate no harm either. If we shift to this third analysis, it includes 19 studies ranging from the 60s up to the 2000s. With more data, do we see a change in the results? Well, this analysis has a ton of data with many, many comparisons that we won't be able to get into here. So I'm going to highlight some and leave more, including cancer outcomes, if multiple factors like weight, age, and more make a difference, for the extended version of this video that you're watching. Believe it or not, there's much more to discuss that I can't fit in here. You can access the full analysis along with all my other analyses, live sessions with me, a private podcast, shortened summaries with applicable takeaways on your health, and much more in the Physionic Insider community. You can access all of that through the link in the description. I'd love for you to join. So, in this Cochrane analysis, if we consider all-cause mortality first, we can see the overall result is no effect one way or another, not favoring more or less omega-6s. If we specifically look at the cardiovascular mortality, we also see similar lack of an effect, regardless of the statistical test used. So, what do we make of all this? We have some analyses saying there's a negative effect, some indicating positive, but unreliably, and most showing no effect. Well, I can answer that based on what we have because there's a few key pieces of information that I've left out so far that will be quite illuminating. But before we shine light on those, let's pour another 150 studies into this analysis using this global meta-analysis. We're straying from our randomized controlled trials and looking at much longer, much bigger prospective observational studies. These studies have a far greater difficulty identifying cause than controlled trials, but they offer certain advantages like having much greater pools of data from hundreds of thousands of participants and over several decades instead of a few hundred participants over 2 or 3 years. So looking at these data and focusing in on all-cause mortality again, we have the study names on the left. You'll notice the different size squares that identifies how much weight or impact that study has on the analysis. We have our trusty one line, and this time if the squares and the overall diamond move to the left, that indicates reduced mortality risk with greater omega-6 consumption, which is what we see here. Okay, a few nuances to be applied here. First, because this is an analysis of associative studies, a statistical test has to be applied to the data to account for potential other factors causing the effect. For example, if people lose weight and they're consuming more seed oils, it's possible that the weight loss is the real reason that they experience reduced mortality risk. As such, the researchers employ what's known as a multivariate analysis, where they account for multiple factors. Here's a list. Unfortunately, because this is such a big analysis, they're not reanalyzing the original data from all 150 studies. And some studies applied all these adjustments, and others only applied some of them. So we can't say that the analysis is universally adjusted for these common influencing factors. This is a potential weakness of the study, and even the researchers acknowledge that. On the other hand, this analysis does something no other analysis does. It also looks at studies measuring circulating omega-6s, not just the consumed omega-6. All the controlled trials that we looked at earlier were measuring dietary omega-6, but many of these studies are measuring blood and cell-integrated omega-6s, which is a better marker of the length of exposure and the amount of real exposure than dietary intake. This is a big plus. In the end, this analysis, with its strengths and weaknesses beyond the scope of this content, indicates increasing omega-6s is associated with better outcomes. Now, if you'll allow me to bring in one more player into this story, we'll discuss it, and then I'd like to return to the beginning before we package this all up into some actionable takeaways. Remember how we discussed omega-3s being a factor? The fats that have been linked to positive health outcomes, the ones found in fish as one example, there are studies comparing circulating omega-6s relative to omega-3s, and they found some fascinating results. If we look at the mortality risk, again on the vertical axis there, and we use a reference of omega-6 to omega-3 in the blood, we can assess the risk of mortality relative to that reference. The reference was set to 4, so 4 units of omega-6 for every 1 unit of omega-3. You can see the reference on the horizontal axis. As omega-3 is reduced or omega-6 is increased, the ratio increases. If the red line moves up, that indicates increased risk. If it goes down from the trusty dotted 1 line running horizontally, that indicates reduced risk. Now, I don't need to spell it out. You can see that if the ratio increases, either more omega-6 or less omega-3, there's an increased mortality risk. Okay, so this might fall in line with the initial Ramsden analysis that we discussed, right? If you diminish omega-3 or overconsume omega-6, you'll see this poor health relationship. Here's the thing though, we need to know how much the average person is exposed to. And according to these researchers and across 85,000 people, the answer is a ratio of around 9. Now, using that 9, if we look back at the graph, that 9 is smack dab at the point of reduced risk. However, the real interpretation is no association with risk. Risk only truly increased when readings got around 14 or a 15 ratio. Why does this matter? Well, it points to day-to-day consumption not leading to dangerous levels of exposure. I should mention 3 things about this analysis too. 1, it is associative across 13 years, but unlike the previous analysis, the researchers were able to use all the raw data to perform uniform statistic adjustment for the confounders here. Secondly, other studies estimate higher omega-6 exposure closer to around 15, right around where risk might increase. However, those older analyses generally use consumption data and assume exposure. This analysis used a sensitive measure looking directly at the blood values, not consumption. So this measure is likely more accurate. And thirdly, the researchers specifically point out that they did not believe that this link is due to increased omega-6, but rather insufficient omega-3. There's more to be said about this particular study, but I'll leave that for the full analysis. See the Physionic Insiders if you're interested. Link in the description. Okay, let's begin bringing this ship home by revisiting our very first debate, this analysis. Okay, remember this? This was the all-cause mortality data. I'd like to take a more detailed look at these 3 studies. Don't worry, I'm not going to go on another 3-study breakdown, except to mention a few things you likely wouldn't know about these studies. The Sydney heart trial that we discussed earlier did show an increase in mortality in the omega-6 consuming group. But what's not mentioned is the fact that multiple researchers have pointed out that the Sydney trial replaced saturated fats with margarine that contained trans fats. Those are the fats that are now banned because of their extreme harm to health. At the time, in the late 60s, scientists didn't know that trans fats were especially harmful. So to be clear, this group of researchers have said that they don't believe that omega-6 group consumed more trans fats, but there's good evidence that they did. I have a separate analysis on this study alone if you're interested in more details on that. So, is it then fair to compare omega-6, including trans fats, against lower omega-6 and lower trans fats? Probably not. There are some other issues with that trial, but I'll leave those critiques for my dedicated analysis. Next is the rose corn oil trial. The omega-6 group consumed corn oil every day for about 2 years. What this Ramsden analysis fails to mention is that the participants also consumed 700 more calories per day than the control group. So, do you consider it fair to compare a lower omega-6, lower calorie diet against a higher omega-6, higher calorie diet, and then blame omega-6s as the sole cause? This is a massive confounding variable. Not to mention, the study included 54 people. Some people didn't comply with the study and more. By the way, These were things discussed explicitly and adequately accounted for in this later analysis. Now, the grand prize, the MCS, or Minnesota Coronary Survey. This one is a doozy because while yes, it's also possible the seed oil omega-6 group consumed more trans fats, that isn't the biggest critique of that study. What if I told you over 70% of the participants dropped out of the study because they were released from the institution that they were being held in? Trying to publish a study where you lose over 70% of your participants in the first year would be wild, but the data was recovered and published anyway. Yet, while this Ramsden analysis mentions the positives of the Minnesota Coronary Survey, like indicating specific cardiovascular risk to women, they fail to mention that tiny matter of losing most of the participants. But it gets better. There is a study called the Finnish Mental Hospital Study, or FMHS, and it was excluded from this analysis because, and get this, the participants were fed trans fats, and the study design was poor. Now, to be fair, those are good critiques and good reasons for exclusion if you choose, but those same exact critiques could be levied against at least the Minnesota Coronary Survey. Not to mention the FMHS study found the omega-6 consuming group experienced significant cardiovascular protection. So we include a bad study indicating harm of omega-6s, but we exclude a bad study showing the benefit of omega-6s. Where's the consistency? Again, to be fair, some of the included trials on omega-3 plus omega-6 also had methodological flaws, big ones, like the Oslo study, which included multiple interventions, not just omega-3 and omega-6 fats. The overall point being here is that this meta-analysis is extremely inconsistent and includes studies of, at the very least, low quality, while also not acknowledging these massive confounding variables. So if we remove all the trials that have significant issues, the Sydney Heart Trial, the Rose Corn Oil Trial, the Minnesota Coronary Survey, and we still are keeping the Finnish Mental Hospital Study out, and even the Oslo trial, we're left with a skeleton of an analysis, and the backbone of this anti-omega-6 argument gets crushed. Still, does that actually mean that omega-6s are not a risk? Just because this analysis was poor doesn't automatically mean that seed oils are beneficial. Well, since most studies on seed oils are from the 50s, 60s, 70s, and 80s, we don't have much data on the current day to look at newer randomized controlled trials. Yet, if we rely on other types of studies like the few that we went over, including what few relatively well-controlled randomized controlled trials remain, the evidence points more strongly in the direction that omega-6 fats have a neutral or beneficial effect in regard to cardiovascular disease and overall mortality. It is possible that too much of these omega-6s could lead to problems. I don't think that we have a clear idea of that, but here are a few actionable things to keep in mind. 1, unless you're downing vegetable oil on a daily basis, your omega-6 levels are likely in the range of neutral or no risk at least, even with regular consumption of other foods that may be exposed to vegetable oils. In addition, most researchers seem more worried about under-consuming omega-3 than over-consuming omega-6. 2, if you're actually still concerned, consider upping your omega-3 consumption to keep your ratio of omega-6 to omega-3 in that normal range, around 4 to 8 or 9 ratio, let's say. Even this is still an area of debate, but you probably will be better off for it regardless. 3, consider that if you avoid seed oils, omega-6s, what are you replacing those with? Other nutrients like certain saturated fats may be more harmful. So while the amount may still be something to leave for future investigations and more randomized controlled trials considering the massive shortcomings of the much older studies are needed, I wouldn't avoid omega-6s altogether, as the available evidence suggests at least some omega-6 consumption tracks with better health outcomes. Anyway, plenty more to get into, but if you want to know more about these studies, check out this video Thanks for hanging out with me, and I'll see you over there.